All right, so let's see if we can do some more practice with solving some circuits. So let's start by, of course, drawing a circuit here. So let's start by, let's see, we got something like this, power supply, and we'll have a resistor right there, and maybe two resistors there. I'll say that's R1, this could be R2, this could be R3. Let's say we've got 3.5 amps coming from the power supply. Let's say this one right there is 24 watts, and let's say this is 8 volts. Okay, now we sort of talked in the previous video that these are a lot like puzzles, and just start by finding stuff, forget what you're looking for, just find whatever you can find. And that's exactly what we're going to do with this one right here, is we are just going to start by finding stuff. Let's see what we can find with the system. And we got this, got that. Oh, you know, let's all here. Let's say this is 12 volts like that. Okay, so let's see what we can find with what we're given. Now, this is a combination circuit. This is a series in parallel circuit is what this is. If I start on the right-hand side, I got the 8 volts there. Doesn't really help me. I know these two, R2 and R3, should have the same current because they're part of the same line, but not voltage. Doesn't really help me here. You know, I'm going to just start over here. Okay, well, I got 12 volts for the power supply. Well, so I know the power supply is 12 volts. So if I go around a pathway, I need to use up 12 volts. So if the current comes like this, and I'd wrap then down, I only go through this one resistor and that's it. Well, that means this guy's got to be 12 volts. That would have to be 12 volts. It's also a parallel section to the power supply. It doesn't go through anything else. It's got to have the same voltage. Well, if this is 12 volts and this is 12 volts, this whole stretch here must also be 12 volts. Well, I've got 8 here so far, and series voltages add up. So this would have to be 4 volts. So each branch would have 12 volts. Remember we said it was like shopping way back when in a previous video. You got 12 volts to spend. If you go through this store, you're spending all 12 volts. If you're going this way, you're spending 8 volts here apparently, and you'd have 4 left to spend there before you come back. All right, so I've got that. What else can I find? Well, I've got the total voltage. I've also got the total current. I could find the total resistance. So my total resistance would be the total voltage divided by the total current. So that would be the 12 divided by the 3.5. So if I do 12 divided by 3.5, I can find my total resistance. So 12 volts, 3.5 amps. Let's see if that helps me with anything. Okay, well, let's see. So that should give me around, I'll round off, 3.4 ohms. There's my total resistance. Okay, what else? Well, R1's got 2 pieces of information. It's got power and voltage. I'm trying to find out something about R1. With power and voltage, current is really easy. So I can find the current in 1 to be power divided by voltage. So it'll just be the 24 divided by the 12, which would be 2 amps. So this one's got 2 amps going through it. Well, let's see if that helps me. Well, I know I've got 3.5 amps coming from the power supply, 3.5, so that splits up here. Well, if 2 amps are going this way, that means I must have 1.5 amps going this way. So it would come around here, go through here, this would be 1.5 amps, and then it would come down here, this would also be 1.5 amps. So now I've got my 2 currents on the R2 and R3, so that's perfect. Because now I've got 2 pieces of information for everything. Okay, well, that's perfect. All right, so let's see what I could find with that. I can find power, I can find voltages, currents, resistance. I can find anything I want. Okay, so let's give you the actual target questions, so to speak, that I was going to ask you for this question. One of them was going to be, what is the current in number 1? Well, we got the current number 1. That's that 2 amps. We have that already. Check, we got that one. I was also going to ask you, what is the voltage on number 3? Well, look at that. We've got the voltage number 3. That's 4. We figured that out already. Good. The only other thing I was going to ask you is, what is the power in number 2? Well, we don't have that yet, but that's easy to find. We've got the voltage and the current. So power in 2 is going to be I2V2. So let's have to multiply those two together. So 8 times 1.5, we've got 12 watts. And there we go. All done the question. Okay. We could also find other things. We could find the resistors and stuff like that. We can find lots of different things, whatever we want. Doesn't matter. Okay, so you can sort of see, just start by finding stuff, linking things together, and eventually you'll probably hit everything you're trying to actually find. Okay. Okay, so let's try something else. Let's get rid of this guy, clean this up. All right, and let's try another circuit. Okay, so let's see, we got a 2-cell battery this time, fancy schmancy, and let's have it come, and we'll even draw a little bit differently. We'll split it up. Got a resistor there. We'll have 2 resistors down here. Have it come back together. And let's put another resistor there. There we go, 4 whole resistors. All right, so we'll call that R1, R2, R3, R4. All right, let's get some values in here. Let's say this one here is 8. Let's say it's an 8 ohm resistor. Let's say we got 0.4 amps going through it. Let's say this one here, let's say that's 6. Let's say that's 6 ohms right there. And let's see what else we can figure out here. Let's say the total resistance is 8.67 ohms. Okay, now let's see what else I can tell you. Let's try, you know what, let's say this. Let's say we know that R2 and R3 are the same. So if one's 5, the other one's 5, but we don't know actually are. Let's see what let's even find out with this circuit. All right, so let's just start by solving for everything we can possibly solve for and see what we can do here. Okay, so I've got 2 pieces of information for R1. I've got the current and I've got the resistance. I'm going to find my voltage over there. All right, so I'm going to find my voltage for number 1. So voltage for number 1 is going to be I1 times R1. So that would be the 8 times the 0.4, and that would be 3.2 volts. Okay, so I've got 3.2 volts right there. All right, well, let's see if that helps me out a little bit here. Now, I know if this is 3.2 volts this way, it has to be 3.2 volts this way. But I also know those 2 resistors are equal down here. So since those 2 resistors are equal, that voltage is going to get split evenly between the 2. So this would be 1.6 volts and this would be 1.6 volts. Now that's only true because those guys are equal. Otherwise it could have been like 1 and 2.2. It could have been 0.2 and 3. But I know those 2 resistors are equal. So I know each one's going to split evenly. Each one gets 1.6 volts altogether. All right, now let's see. Current. I don't know how much current is in the bottom. I think there's not really much else we can solve for. Well, let's see. I do have the total resistance, though. I do have that, and I have R1 and R4, and I know R2 and R3 equal. So let's see if I can figure this out then. Okay. So if I calculated the total resistance, I would have found the resistance of those 2 and put them together. Use my parallel expression to find out that, and then I would have added the 6 at the end. So I'm going to start by subtracting the 6. If I subtract R4 from this, if I subtract the 6 from that, that's 2.67 ohms. So I know that this section here, that parallel section, that entire thing has to be equal to 2.67 ohms as an equivalent. So if I would set that up, I know that 1 over 8 ohms, there's my 8 right there, plus 1 over these 2 guys put together, R2 plus R3, to the negative 1 inverted would have to give me 2.67. Okay, or sorry, 1 over 2.67. So I know these guys are equal to each other. Well, that's really only one unknown, not 2 unknowns, because I can just write this as 2R2 or 2R3, doesn't matter. So I can use this to solve for what my resistance, actually we're going to switch this, it was already inverted in the thing, it would be 2.67, there you go, that's better. I can invert this, and I can solve for R2 and I can solve for R3. So if I do the basic algebra, if I get rid of this inverse over here, so 1 over 8 plus 1 over 2R2, you could do it that way if you want to, gives me 1 over 2.67. So just working with that parallel section over here. Okay, now it's basic algebra. Subtract the 1/8 from both sides, invert it, divide by 2, and you can calculate what R2 has to be. Okay, so incorporate a little bit of algebra, a little derivation into it. Okay, so let's solve for R2 and see what we get. All right, so punch out. You should get around 2 ohms. So R2 is 2 ohms. So this one's 2 ohms. And since they're equal, that one is also going to be 2 ohms. All right, well, now I've got information down there, so let's see what else we can do. All right, so I could find the current down here. Let's see, current number 2 would be the 1.6 volts divided by 2 ohms. So that gives me 0.8 amps, which means this guy over here must also have 0.8 amps, because same calculation for that one. It's part of the same line, so it shares the current. So let's see what else we can do. Well, I know I've got 0.4 amps going this way, and I've got 0.8 amps coming that way. They will come together and join up right there and keep on going, which means this one right here has to have 1.2 amps flowing through it. So if I know that one's got 1.2 amps going through it, I can find my voltage in number 4 using Ohm's law. So I4 times R4. So 6 times 1.2 will give me 7.2 volts. So this resistor right there is 7.2 volts. Okay, well, now I can sort of piece things together. I've got going all the way around, I've got all my voltages come around. I've got 3.2 volts going that way, or you could go this way. You got to pick one or the other. And then I wrap this way, come up, I got 7.2 volts there. So if I put them all together, my power supply must be 10.4 volts altogether. Now another way you could have done that is to find using the total resistance multiplied by the total resistance. So total current and total resistance. So you could have done the 8.67 times the 1.2 would also have worked, or just pick up one pathway, go through the pathway and add the voltages, doesn't matter. Okay, and with that, we pretty much so. We could find the powers if we wanted to, but we found, usually you want to try and find at least 2 things for each component, and we did that, and there you go. So sometimes, you know, it gets a little different because here we had to sort of reverse engineer our total resistance or equivalent resistance expression a little bit, work backwards a little bit. And then once we had that, it's all the same type thing we practiced before. Okay, so there's another little question and practicing some Ohm's law, Kirchhoff's rules, and how to solve circuits.